A spring has a natural length of 20 centimeters. If a 25 Newton force is required to keep it stretched to a length of 30 centimeters, how much work is required to stretch it from 20 centimeters to 25? Okay, the first thing I notice is I've given this force and it's given to me in newtons. So I'm in SI units. And because we're using newtons and that involves meters, any lengths we use with that force needs to be in meters. So we're going to need to convert these lengths to meters, and to go from centimeters to meters, we'll need to move the decimal place 2 to the left. Now, thinking of a spring mass, force equals kx. I'm not sure why my pen stuff is dragging, but I'm just going to have to leave it. Can't get it to stop. Okay, so we're going to plug the force in, which is 25, and that's going to equal kx. And what x is the distance or displacement, how far the string is stretched or compressed. And it says when we apply 25 newtons, it will keep it stretched to a length of 30 centimeters from 20. So it's actually stretched by 10 centimeters or 0.1 meters. So that is the displacement or stretching from the natural position of 20 centimeters, stretch it out 10 centimeters to 30, and 10 centimeters in meters is 0.1. So that means K is going to be 25 divided by 0.1. And so that just moves the decimal over. So K is 250. Now I'm ready to do the integral for variable work. And that the force due to the spring is Kx. And then the distance is just the dx part. We're going to sum that distance up. And we're stretching it from 20 centimeters, which is at equilibrium. So we're going to call that 0, to 25 centimeters, which is 5 centimeters, which is 0.05 in meters. So this is the work done. So to stretch it that 5 centimeters. And then we can go ahead and put in our K, which was 250. So the integrals for these are generally pretty easy because Kx is easy to integrate. It's just 1/2 Kx squared. So we've got 250 x dx. And so that's going to be 125 x squared evaluated from 0 to 0.05. And so when we go ahead and put that in, we're going to have 125 times that 0.05 squared minus 0, value at the lower limit. So I'm going to go ahead and simplify that. So I'll go ahead and do 0.05 squared times 125, and it looks like that's 0.3125, and we're in an SI units. The work unit is joules.